overview and lesson on simplifying radicals. First of all, when I'm simplifying radical numbers, I always like to copy square numbers, as many as I can do, on the side of my paper. It's very, very helpful. You might remember that square numbers are any number beginning with 1 squared. And squaring a number is nothing more than multiplying a number with itself. So 1 squared is 1 times 1, or 1. 2 squared, or 2 times 2, 4. 3 squared, or 3 times 3, 9. Why don't you pause the video for a moment and see if you could write down all the square numbers, or remember all the square numbers 1 to 400. Go ahead. Okay, let's see how you did. We already had 1, 4, and 9. 16, 25, 36, 49, 64, 81, and finally 10 times 10, 100. Let's see if we can get the next 10. 11 squared, 121, 44, 169, 196, 225, 256, 289, 324, 361, 400. So there you go. Those are the first 20 square numbers. For those of you who forget, there's a nice simple way in your graphing calculator. You can just go turn on your calculator and go to y equals and just ask the calculator to give you all numbers x squared. Y equals x squared. And then hit the second button and go to your table. And you'll notice that on the right side are all the square numbers. And on the left side are all the numbers that you're squaring to get those numbers. There's 11 squared, 121, 12 squared, 169, 196, 225, 256, 289, 324, 361, 400, and of course they still keep on going. The nice thing about this is that not only do you have the square numbers in the y column, but you have their square roots in the x column. So let's never forget that the only numbers that give you nice, clean, rational answers inside a radical are square numbers. For example, if we have the square root of 169, that right there is going to be a nice rational number because 169 is a square number. And what number times itself is equal to 169? That's right, 13. So you don't really need to worry that much about simplifying radicals with perfect square numbers inside, because those will always equal rational answers without square roots. So what would be the square root of 400? Well, the number that multiplies with itself to get 400 was, that's right, 20. The square root of 9, that's right, 3. So, in summary, the square root of any square number is equal to a rational number, and that is very simple to do, because if you put any of those into your calculator, second x squared button opens up a square root, and you put any perfect square number in, you're going to hit enter and get a nice, clean, rational number. Well, Today's lesson is going to be, well, what happens when we put a number inside a square root, which is not a perfect square, like 2? Well, then you might remember that that gives us a non-repeating decimal that almost fills up the whole entire screen. These are irrational numbers, and today's lesson is going to be, what do we do? How can I simplify a radical, square root, that doesn't have a square number inside of it? For example, the square root of 12. Well, let's go through that step by step and see how simple this actually is. I'm going to bring over a square root here and make it a little bit bigger, and I'm going to put in the number 12. Well, here are the steps I like to follow. First of all, I still like to have those perfect square numbers on the side of my page. However, if the number 12 is inside the square root, I really don't need my list to go much higher than that. So I'm just going to put the first couple numbers here on the side of my page. Once I get to 16, 16 is bigger than 12. So those are all the perfect square numbers I'm going to need for this particular problem. So I can stop right there. Well, my next step is to take the number that's inside the radical, in this case number 12, and make that famous T-chart on the side of my paper and write down all the factors of 12. Well, we know that 1 goes into all numbers, and 12 would be the other factor. 1 times 12 is 12. 12 is an even number, so I know 2 goes into it. 12 divided by 2, 6. And finally, I know that 3 goes into 12. How many times? 4. 1, 2, 3, 4, 6, and 12 are all the factors of 12. Well, my goal here in simplifying this radical is to try to find, of all the 6 factors in this case of 12, what is the largest square number, if any, on this list? Well, if I start at number 1 from the smallest to the biggest, well, I know that 1 happens to be a square number, but 1 goes into all numbers. And if we divide 1 from 12, we're just going to get 12. So 1's not really going to be that useful for us in this process. But is there another one? And the answer is yes, 4. 4 is the largest factor of 12 that's also a square number. That makes it extremely useful in this problem. So once I have that number, I'm going to go back to my square root of 12, and I'm going to basically divide it into 2 square roots. On the left side, I'm going to put that perfect square number, which in this case was 4. And on the right side, I'm going to put the other number that multiplies to give me 12. In this case, it's right here, the number 3. The square root of 4 times the square root of 3 is the same as the square root of 12. Well, there's only one more step. The reason why we put this perfect square right here on the left side is because it has a nice, clean, rational answer. The square root of 4 is 2. Now, there is no square root of 3 that's nice and clean, so we're going to keep it inside the radical and get a final answer of 2 radical 3. Now, there is a nice way to check that you simplified well with your calculator. So I'm going to clear out my calculator, and I'm going to start with second x squared, which opens up the square root, and I'm going to put in 12 and hit enter. And I could see that gave me a 3-point non-repeating decimal, 46410, right? Nothing's repeating. It's kind of like a crazy number. It's an irrational number. Well, if I successfully simplified it correctly, 2 radical 3 should be exactly the same as radical 12. So in the calculator, without clearing out radical 12, I'm going to put 2 second x squared 3, 2 radical 3, and hit enter. And if those 2 crazy decimals are exactly the same, then odds are I simplified my radical correctly. Okay, let's practice. Here are 4 different problems. Let's see if you can simplify each one. Go ahead, press pause and give it a shot. Okay, let's see how you did. Well, what I'm going to do on the side of my paper, since all of these problems are on the same piece of paper, I'm going to write down all my perfect squares, like I like to do, on the left side. And the biggest number is 72, so I'm going to keep on going until I get past 72. 1, 2 times 2, 4, 9. These are numbers that everyone should kind of learn, memorize, like any other multiplication table. Perfect squares, until it's really easy just to write them. I'm going to stop at 81 because 81 is bigger than 72, so I'm not going to need any more squares past that. Well, let's start with the square root of 27. Well, my first step is to take 27 out, make a t-chart with all its factors. 1 times 27, 3 times 9. That's all there is for 27. Now I'm going to actually start from the biggest going down and see if any of these numbers also happen to be perfect squares. Well, 27 isn't, but 9 is. So I can simplify the square root of 27. So I'm going to start by dividing it into 2 square roots. I'm going to put the perfect square number, 9, on the left side, and the other number that multiplies by 9 to get 27 on the right side. The reason why I do this is because the square root of 9 can be simplified into a regular number 3, because 3 times 3 is 9. However, the square root of 3 is irrational, so it's going to stay inside the radical. And that's going to be my final answer, 3 radical 3. And again, I'll show you the check. The square root of 27, let me clear that out. Second, the square root of 27. And then I'm going to put 3 second x squared 3 and see if it's the same number. And sure enough, it is. So I successfully simplified the square root of 27 to 3 radical 3. Let's try the next one, the square root of 50. I already have my square numbers written, so I just need the factors of 50. 1 times 50, 2 times 25, 3 is not a factor, 4 is not a factor, but 5 is 10 times. Well, those are my factors of 50. Well, I'm going to start from the biggest to the smallest. Well, 50 is not a square number, but 25 is. So I'm going to separate the square root of 50 into 2 square roots. I'm going to put my perfect square, 25, on the left, and 25 times 2 equals 50. And the square root of 25 is 5. Radical 2. Now, this next problem, 72, you might have noticed has a lot of factors. So it's a good one to practice. So I'm going to put 72 up here. And I'm going to go all the way down. 1 times 72, 2 times 36, 3 times 24, 4 times 18, 5 doesn't go in, but 6 goes in 12 times, 7 no, but and 8 times 9. Now this is a tricky one. It's always important to remember that what we're looking for is not any square number that goes into a particular number, but the largest one. This particular problem often gives people problems because everyone kind of knows that 8 times 9 is equal to 72, and they want to use 9, which is fine, but you wouldn't be simplifying this radical to its most simple form. So a good habit when you're simplifying radicals is to always start with the larger numbers and go down. Well, we know that 72 isn't a perfect square. We wouldn't be doing this. Well, the second largest factor of 72 happens to be a perfect square. So that's the one we want, not the 9. So I'm going to separate the square root of 72 into 2 square roots. I'm going to put the square root of 36 on the left and 2 on the right. And the square root of 36 is 6. Radical 2. Well, our last problem, you might notice, has a number in front of it. Well, radicals always technically have a number in front of it, and if you don't see a number in front of a radical, you could assume that it's the number 1. And the number 1, at the end of the day, isn't there because when you multiply 1 by anything, it's always the other thing, which is why it often disappears in math. Well, but any other number besides 1 is super important to write. So here we basically have 2 times the square root of 8. Well, in this particular case, I'm going to start this problem by not worrying so much about that 2. Later on, it's going to come into play. So I'm going to simplify the square root of 8 the way I do any other number. I'm going to write down 8. I'm going to write down its factors. And I can see that 4 is the largest factor of 8 that's also a square number. So I'm going to divide the square root of 8 into the square root of 4 times the square root of 2. But one thing you have to remember is that this 2 over here is still out here kind of multiplying with everything. So I'm going to drop it down in front of that. Well, the square root of 4, we all know, happens to be 2. But we still have this other 2 over here, and it's multiplying by everything, and this stays the square root of 2. And now, the final step is to take that 2, which was outside, and multiply it by our new number that's outside, and you get 2 times 2, which is 4 radical 2. And we will practice more of those in the lessons to come.